Hello, my dear students. As you can remember, my full name is Magawana Gulbahot Muratovna. And in our previous video session, we explored chemical bonding in inorganic compounds, looking closely at how atoms come together to form different types of bonds. Understanding these bonds is crucial as it forms the foundation for our next topic. And today we are going to talk about acids, bases, and salts. Let's get started. Many acids and bases occur naturally in nature, such as citric acid in fruits like orange, lemon, tartaric acid in tamarind, malic acid in apples, and lactic acid in milk and milk products, hydrochloric acid in gastric juices. Similarly, many bases are found as a lime water. We use many of these acids in our day-to-day life, such as vinegar or acetic acid in the kitchen. Experimental definitions for acids, bases, and salts focus on their observable behaviors in laboratory settings. Acids are substances that produce hydrogen ions, H, when dissolved in water, which can be tested through their reactions with indicators and metals. For example, a litmus test, acids turn blue, litmus paper red. Reaction with metals, acids react with reactive metals like magnesium and zinc. Bases are substances that produce hydroxide ions when dissolved in water. And a property confirmed through color change reactions with indicators and their reactions with acids. So bases taste bitter, turn red, litmus paper blue, and then neutralize acids. As for salts, salts are neutral substances, don't affect litmus paper. And these experimental definitions rely with observable laboratory, making it easier to identify acids, bases, and salts by their distinct reactions. Acids are substances that donate protons when dissolved in water, and they have a pH less than 7. As for properties, acids characterized by their sour taste. Litmus test, acids turn blue, litmus paper red. As for hydrogen liberation, acids react with some metals to liberate the hydrogen. Acids have numerous applications from digestion to manufacturing, cleaning, and food preservation. So, bases have a pH greater than 7. As for their properties, they are bitter taste and slippery, like soup, baking soda can conduct electricity when dissolved in water, react with acids to form salts, and water in neutralization reactions. A litmus test, they turn red, litmus paper blue. And bases are essential in household cleaning products, manufacturing, even in biological systems like by bicarbonate buffer system in blood. Salts formation. They are formed by the reaction of an acid and a base. Ionic structure. Salts are composed of positive charged cations and negatively charged anions. Electrostatic forces. The ions in salts are held together by electrostatic forces. Ionization and dissociation. Ionization, what is it? When an ionic compound separates into its already existing ion upon dissolving in water. For example, sodium chloride dissolves in water and splits into ions. Ionization. It's when a neutral molecule gains or loses electrons to form ions. This usually happens when certain molecules dissolve in water. For example, it's hydrogen chloride. These processes are crucial in understanding the behavior of substances in water, including the electrical conductivity, acidity, and the reactivity. The Arrhenius concept of acids and bases, introduced by Svante Arrhenius, defines acids as substances that produce hydrogen ions in water and the bases as substances that produce hydroxide ions in water. While it was a groundbreaking theory, it has some limitations that restrict its application. Here are some main limitations. The first one is water dependency, the second is non-aqueous solvents, the third is salt formation. The Bronsted-Lowry concept of acids and the bases, developed by Johannes Bronsted and Thomas Lowry in 1923, expanded on the Arrhenius concept and provided a broader definition of acids and bases. According to this theory, an acid is a substance that donates a proton to another substance. A base is a substance that accepts a proton from another substance. Dear students, that is the end of our video session, and the next time we are going to speak about coordination chemistry. Thank you for your attention. Goodbye.